What is going on, everyone, and welcome back. I hope you all had a good New Year's and Christmas. So we are going to get back to work. And on this episode, we're just going to kind of update some of our code, maybe upgrade some of it to optimize how it's running and all that good stuff, just to kind of smoothly transition back into programming after the month. And I wanted to show you after the last episode, I spent another hour or whatever just kind of messing around, and I got this into here, which is another thing that we're going to be adding. It won't pop up with this open thing, but let's see here. On my desktop, I made a script called play. So if I import that, and this is all during runtime, and then I can add this component. So that's another thing we're going to be doing here soon. So I just wanted to throw that out there as well, that we will be building the engine as a full standalone. So we will be able to import scripts at runtime and use custom folders wherever on your computer. It doesn't really matter. We're going to eventually get rid of being independent instead of being dependent on any kind of IDE. So we're getting onto that. So right now we need to just kind of change some things around, and I made kind of a list on what all I need to change, which a big one is right now how we added it, how we did the FBO in the last episode. On the clear color, let's say I change that to green. If we try to run this, then what it's going to do is it's not going to clear. As you can see, this background right here it's still black, it's not green. And the reason is because I put them in the wrong spots whenever we did this. The clear color for inside of the renderer class, you actually need to move this up above the clear. I know it sounds kind of funny, but that's just how we have to do that. And then in core, we need to, because right now it will clear, but it won't clear back to black. So actually let's pull this up just so that I can show how clear color works whenever you're dealing with multiple FBOs and stuff like that. I will comment out this. You don't have to do this, I'm just kind of demonstrating. And I hit play. So how this is you can see it had black over here because that's what we cleared it to, and then it transitioned over to green, and now all of this is green back here, and we are supposed to be just green right here because that's where we want it to be. So, or that's where we're drawing it, so it shouldn't Nothing else should be green at all. So, hold on just a second. Okay. Apparently he just wanted to tell me that he was playing a different game. Alright, so for here, inside of the core, we just need to take clear color, take it out of there, and put it right there. So now if we run it, it should be exactly how it's supposed to be. There we go. So now that we can see that working, to uncomment that, now it'll look exactly the way that it should. And there it is. So that fixes the clear color issues. I don't know if you've came across that, but all right. Another thing is we need to add some things in the game object class. There's some things we are going to be using in the future, which right here we need to add a private static int h, since I is already taken. We're also going to be using dirties, which I'm not going to add that yet. It just checks to see if position, scale, or rotation has changed, since we're not doing rotation in this episode, and we're going to do it here shortly. I'm not going to add that. Alright, so we have a get component string. We need a remove component string. I don't know why we didn't add this before. String s. We're basically going to do the exact same thing. Components dot get I dot name dot equals s. Oh, I also need to return out of this. Let's return out of that one. I didn't see that we weren't returning out. That just ensures that we're not continuing through the loop. So if we have 15 components and we're removing the first one, we're not going through another 14, even though we removed the one that we needed. Alright, and another is we need a find method. That way we can find static. Find game objects that are in the scene. Public static void find string s. And right here, this is where we will use the h. So for not j, for h equals. What am I doing? Oh, come on. A little rusty. Slower than instances dot size h plus plus. There. Then we're going to say see here. Game object G equals instances dot get H. Say if G dot name dot equals S, then return S. Oops. It doesn't need to be a void, it needs to be a game object. No, return G. And here, return null. So that allows us to find a game object now. So we got remove, find, let's see here, add component. I put the add component right here. So I need to, and here we need to check if B equals null. Then we're going to say, yeah, let's use the debug. Debug.log could not find behavior. And exclamation mark. And then we're just going to return out of it. Because even though there's a behavior here, we need to check if it's null so that we're not passing in null and trying to initialize it with null. And we'll be using that later as well whenever we're adding components from outside of our jar file or outside of our path. Okay, another one is, yeah, and there's a lot of stuff in the game object class that we're going to be changing. We need a public void prepare. And what this method is going to do is it's just going to prepare the game objects and find game objects that have a sprite renderer attached to it. And later on it's going to have a lot more stuff as well, but for right now that's all it's going to be. It's not going to be a public void, it's going to be a public static void. And here we can use H as well. So we're going to go for H equals, come on, what in the world? H equals 0, H is lower than instances dot size H plus plus. Okay. And then we're going to say list of logic behavior components equals instances dot get H dot components, and that will store all the components for each game object instance we have. And then we'll say if how am I going to do this? Now let's make this God. Yeah. Yeah, I could just use it. I'll just use a get component for right now. Why not? No. No. Sorry, I'm changing stuff at the last minute. Probably shouldn't. We're going to make this not a static, but a regular void. And then here we're going to say components dot size, and then this is going to be a logic behavior component equals not instances dot get h components dot get I. Let's change that to I. And then say if component dot name dot equals sprite renderer, then we are going to call renderer dot add to renderer component. We need to make this a logic behavior. Why did you put it way over there, you stupid? Isn't that right? Oh. Oh no, I need to turn this into a sprite renderer. Yes, sprite renderer. Because it's already a logic behavior, duh. Alright, and I believe that's it for that method. Now, right down here, now we will do the exact same thing. Public static void prepare objects. And we'll do the exact same thing, but we are going to use H. And then this will be instances. And then we're going to call game object G equals instances dot get H. And then we're going to call G dot prepare. There, that should do it. In the core, instead of adding that, I want to call GameObject dot prepare objects. And that should basically do the exact same thing. Beep, 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 beep. Yep, there it is. So it's automatically being rendered now. Alright, now next thing. How far are we in here? Okay, 20 minutes. We need the ability to check if it's been minimized, because if we run it right now, if you remember when I was messing around and I hit minimized, notice that it throws this error message. And it's because the application has been minimized, so now the size is 0. So it just messes up everything for rendering because we're checking the size of the application. So right here we'll put private static. We use byte. Minimized equals 0. And right here we'll say if w equals 0 or h equals 0, then we know that the application has been minimized. Yeah, that'll work because we're never going to shrink it left to right or up and down 0 anyway. So if any of those are 0, then it's minimized. Okay. So then minimized equals not true, 1. Right here we'll put public static boolean is minimized. Then we're going to return 1 or minimized equals 1. Right? No, 0. Because we're checking if is minimized, not if not minimized. And then right here in the core, we need to check if it has been minimized. Otherwise, we don't want to mess with it. So we need to say if application dot is minimized, if not application dot is minimized, then we will do all this stuff. Then that should fix that. What am I doing wrong? Minimized equals 1. Yes, 1 is true, 0 is false. Cancel. Yes. Okay, there we go. And there it is. Now it works without any kind of errors. The next thing we need to fix is, as you can tell, everything is perfect. Everything is rendered how it's supposed to be. But if I stretch it, something stupid happens. What in the world? Let's change that to and. That was dumb. I haven't seen that before. Oh. Else minimized equals 0 for 1. Oh, please don't go all black. Okay. So as you can tell, now it stretches out. And it's acting all weird. And that is because we're not adjusting our FBO size based on our application size. So right here, I need to say renderer dot update FBO. I'm going to pass in W and H. We have not created this yet. So way down here at the bottom, I'm going to say public static void update renderer. And it's going to take in a float W, float H. Let's take that away. I'll say update renderer, or update FBO. And pass in application.width, application.height. Application.width, application.height. And apparently that, what did I name it? Update renderer FBO. FBO. Okay. And this, change this to W and change that to H. Y. Really? What if I just do that? How about that? Does that work? There. Alright, so now that those are ints, now this should work now. There we go. Now it stays its proper size. It doesn't go all goofy. Now, last but not least, for updating, anyways, well, addition stuff. Right here, we need a couple extra methods. For one, I need to say public vector to v, and then say this dot, or no, x equals v dot x, y equals v dot y. That way when we create a vector, we just pass in that as well. And here say public void set float x, float y, and then do exactly the same as we did up there and say this dot x equals x, this dot y equals y. That way we can set it using just floats. Now we need to add some mathematical stuff, so say public vector to add. I'm going to add a vector to v, and all this is going to do is going to say return new vector 2 x plus v dot x and y plus v dot y. Public vector to add float x, float y. Do the same thing. Do vector 2. Say this dot x plus x, this dot y plus y. And right here, I'm going to say public vector to add float v, and then return new vector to x plus v, y plus v. That way we can add a float value as well as a vector value. So what we're going to do is we're going to copy all this, go down here, paste, paste, paste. All we have to do here, go sub, 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 change that to minus, 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 minus. All right, and then we're going to do the same here and just do multiply and, well, so mul and div. And so just change those to multiply, change those to divide. All right, I'll go ahead and add that real quick. All right, and it should look like this. And then that ends the Vector2 class for now. We still have a bunch of other methods to add later, but that'll do. That'll do for now. That way we have a little bit more functions to work with. Now, the absolute last thing that we need to do is optimization. And we are going to hit, I put it in here. We're going to optimize the mouse class. And it's going to be fairly simple. You're going to change these from booleans to bytes. And I explained this in the last episode. For inside of the engine itself, we are going to be using bytes instead of booleans. And that is because any button goes false. It's a lot faster, or not faster, but it takes less memory, like a lot less memory. So we can return a boolean, but we don't want to do any of the storing and stuff like that as a boolean, because we want to use less information as possible. We're going to remove this. For one, we don't need that anymore. We're going to make it a lot more optimized. And all we need is buttons down I. Zero. It's going to be the exact same thing with buttons up I. Change this to buttons down dot length. Change this to buttons up dot length. And then it'll be down buttons equals 0, or any buttons down. Any buttons down equals 0. And then oh, I didn't have an S. Any button down, any button up equals 0. Any button equals 0. And for the invoke class, let's see here. If it equals key press, let's shorten this a bit. I don't like staring at all that. to say if action equals key press, then buttons down, button equals 1. And then say buttons button equals 1. Buttons button equals 1. And then here will be very similar. Except for it's going to say buttons up equals 1. And then buttons button equals 0. And then here, I think I could just completely remove that. And any button, of course, equals 1. We will mess with the I don't know. Hold on, just go ahead and get this. Any button equals 1. Return buttons equals 1. Yeah, so then we're just going to change all of these to, so turn any button down. Going to return any button down equals 1. And that 1, 2, 1. Go any buttons up equals 1. Change that to equals 1. What? Oh, any button up. Let's change that to any button up equals 1. I hope I'm doing this right. Pretty sure I am. Okay. Any button down equals 1. Get rid of these. And then that should be it. That changes all the booleans to bytes, which makes it a lot smaller in size. And everything is working like it should. There we go. So next episode, we are going to go ahead and move into making the engine be able to compile. Because as of right now, if you try to compile it, it is not going to work. And the reason is because, like I explained before, we will not be using file format because inside of a jar it is not a file-like format. We'll be using input streams instead, which is very similar. There's not much extra code you have to add, but it is slightly different. Let's see here. Oh, that's another thing I could do really quick. I know we're a little bit over time, but we'll probably go ahead and add it. I don't even know what I'm looking for. We'll say texture. And this is not the one that you guys have. It's the one that I have. I'm just using it to compare. So right here we are using stbi load dot resources textures file name blah blah blah. Instead we are going to have to use an input stream and actually read in the bytes and use stbi load from memory buffer. And reading in just normal files will be a lot easier. As it or it's about the same. All we do is we just use import or yeah, importing the asset as a stream. So it's just one extra line, and then we just change how we do that. So really quick, let's open up shader. We'll open up shader. So the first one is the one that you guys have, what we've been doing. And the second one over here is what you guys do not have. Let's see here. I don't think I changed too much. So and here's where I'm at. You know what? We're not even going to mess with that. Basically, what we're going to do is we're going to, instead of using two shader files like the fragment and the vertex shader, we're going to combine that into one shader file. So it'll look like this. It'll be like default GUI.shader or default game.shader. How we have it right now is separated into fragment shader and vertex shader. And since we're going to be importing all the files from folders or inside of the jar, it'll look for whatever package it's in. We don't want to be looking for two separate files. We want it to be one. And it's super simple. All we do is we just open up the vertex shader, and then right at the very end just put end vertex, and then below it copy in the fragment shader. And then whenever we import that file, all we do is we just split it at that end vertex line, and then it splits it into fragment shader and vertex shader. And then we just pass it in. So it's really, really easy. I just don't want to get into all that. I didn't realize that I was passing in another function and whatnot. And I kind of want to do the same thing uh, for what you guys are doing as well. So, next episode, we're going to go ahead and make it able to build. So we're going to change all that stuff to using input streams. So by the end of next episode, you will be able to run it from a jar file from anywhere. All right. Well, thanks for watching, and sorry I'm a little all over the place. Next episode will be better. Kind of got the coming back jitters or whatever, losing my mind kind of thing. But I will see you guys next week, and we will kill it. All right. Bye, guys.